Hey folks, today's topic, the first section of Unit 4. You'll like Unit 4. It's pretty much solving, graphing a little bit. It's these things called systems. So when you're looking at a system, that's a situation where you have two or more equations occurring at the same time. The solution to a system is the point that works in the first equation and works in the second equation at the same time. That's what we would call the solution. So for me to figure out where this point and this point, what points they have in common, I would just graph them and see where they intersect. So let's do it. So we have two different forms here. We have slope-intercept form and we have standard form. So we're going to do a quick review of how to graph each one of these. So slope-intercept form, you start with the slope. I identify the slope and I identify the y-intercept. Slope is -3/2. Y-intercept is -3. So B stands for begin. That's where you're going to begin. So I'm going to begin at the y-intercept of -3. And then our saying for slope is rise over run. So my rise would be -3. Notice this negative out front, I chose to put it with the numerator. You could put it with the numerator or you can put it with the denominator. You cannot put it with both. If you put the negative with both of these, then you would have a negative divided by a negative, which is actually a positive. So you could pick whichever one. It looks like I put it in the wrong spot because if I go rise -3, I run out of room. So I'm going to do the reverse of down 3, forward 2, and I'm going to go up 3 and backwards 2. So up 3, backwards 2, up 3, backwards 2. And then if I go again, I'd run out of room. So that's enough information. You really only need 2 points. I always like to draw. Hopefully I can squeeze in 3 and make sure that my first 2 points were correct. And then I grab a straight edge, play connect the dots, and we have a line. Now I want to do this again for my other equation. The other equation is in standard form. Standard form, we do what's called the cover-up method. That's where we put a 0 in for x and solve for y, put a 0 in for y and solve for x. So when I put a 0 in for x, that means the x term is gone, and I have an equation that says -4y equals -12. Divide by -4, and we get 3. And then I put a 0 in for y. That means the y term now is gone. So I have an equation that says 6x equals -12. So x equals -2. And then I plot those 2 points and play connect the dots. 0, 1, 2, 3, -2, 0. Now don't forget, the picture alone is not the solution. The solution is where these two lines intersect. So I like to circle it to remind myself that that's my solution, and then I actually write the answer as a coordinate pair. -2, 0, if I plug that into the first equation, it would work. If I plug it into the second equation, it would also work. All right, let's have you try example 2. Pause it if you haven't yet. Okay, let's see how you did. So let's see, this is cover up. I'm not going to show my work on this one. I'm just going to go ahead and do it. We've done graphing for a long, long time. So x is -2. Y is +2. They connect the dots. Slope-intercept form, start with your y-intercept, 1, 2, -3. My slope would be down 1 over 4, down 1, 1, 2, 3, 4. So up 1, back 1, 2, 3, 4. All right, so this is one of those scenarios where depending on how nicely you graphed your lines, they sometimes won't exactly hit. I did a nice job. Mine hits exactly at that lattice point there. If yours doesn't, I'll give you the benefit of the doubt. As long as you get close, usually you can pick a lattice point as your answer in this class. I usually set them up that way. So I'm going to circle this as my solution. That's what? 1, 2, 3, -4, -2. Box it in, put it up on my fridge. All right, now we get to the fun ones. So these aren't just linears. These are our transformed functions from Unit 1. So this is where you're going to do some shifting. You're going to look at the family of functions, and then you're going to look at stretch, shrink, neithers, and reflections. So let's take a look at shift. Is it on? Yes. So next to x, there's a -2. That means I'm going to go forward 2. And then not next to x is subtract 4. So that's going to be the same in the y direction. So my vertex, my shift is +2, subtract 4. 1, 2, 1, 2, 3, -4. Now my family is the squared family, and we have a multiplier of 2. So as I move over 1, remember you can kind of cross these out. They don't really matter anymore. So 1 squared is 1 times 2 is 2. So I'm going to go over 1. I'm going to go up 2. Put in 2. When I go over 2, that's 2 squared is 4. 4 times 2 is 8. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And because I know that the family of quadratics has symmetry across the vertex, across the axis of symmetry, I should probably say, I can then just sketch the other side from there. So there's my first one. Oh, nice. Our second one is a line. So here we go, slope-intercept form. 1, 2, 3, -4. My slope, remember you can always make a number into a fraction, putting it over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Grab my straight edge again. Connect the dots. Now, before this class, probably all of your systems were linear. So we're going to look at some systems that are not just linear, and that's going to give us more than one solution, which we can then highlight here. I've got this intersection and this intersection. So my first point is at 1, -2. And then 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. So this system had 2 solutions. There are 2 coordinate pairs that you could plug in for x and y up here and get an equation that is equal. Yeah, you could probably do the next 2. I'll encourage you to pause. Try to do the next 2 on your own. All right, let's see how you did. So the shift is on. 1, 2, 3, 1, 2, 3. This is a square root family with no multiplier. So that means no reflection and no stretch, shrink, or neither. So over 1, up 1. 1, 2, 3, 4, up 2. Then I sketch my other one. Shift is on again. So this is going to shift backwards 3. 1, 2, 3, down 1. It's the squared family with a reflection. So it's not a stretch, shrink, or neither, but there is a reflection. So over 1, down 1. Over 2, down 1, 2, 3, 4. And then symmetry allows me to draw the other half. So these two, they end up only intersecting once. So circle that intersection. That's at the point -2, -2. Ooh, we get an absolute value and a cubic this time. How exciting. All right, so shift is on, -2 plus 1. The absolute value family is over 1, up 1, but I've got a stretch of 2, so over 1, up 2, over 2, up 1, 2, 3, 4. Then symmetry, I know that the absolute value family has symmetry. Connect the dots. And then we've got the cubic family. We've got the shift again, so over 1, up 1. My over 1, up 1. Yeah, my old notes were wrong. So from here, I've got a stretch factor of a half, so over 1, up a half. Over 2, so what's 2 cubed would be 8, but then we're cutting that in half, so that would only be 4. 1, 2, 1, 2, 3, 4. I know that the cubic family is odd, so I can draw the other half of this picture using the odd symmetry of rotational symmetry around the origin. Now, if this wasn't notes, I would probably double check this to make sure that my graph, that I graphed that right, because these two don't intersect, but that's okay. In this case, that was my goal, was to have them not intersect. And so we would say no solution. So it's okay for your two graphs to not hit each other. When they don't, it means no solution. But when they don't, I would double check to make sure that you graphed them correctly, because most of the time I'm going to have them intersect. All right. So this last one, I just wanted to show you how to do this on your calculator, especially for my AP Calc kids. Oh, actually for anybody. When you go to college, they probably won't make you draw everything by hand. So you can use your calc to save you a bunch of time. So I'm going to go to my calculator, input these two equations. So -2 natural log of x plus 3, close it, plus 2. And then the second one, I'm going to do my alpha f1, so I get a fraction, -1 to the quantity of x subtract 2 squared. And then at the end, I got to put a plus 2. I'm going to do a zoom 6 and see if that window is a good enough window for me to see where they intersect. So there's my first function. There's my second. Okay, yeah, that's enough of a picture. I mean, I could do a little box. I could do a zoom box if I wanted to zoom into those sections, but I see that they intersect 3 times, so I have to figure out where those 3 intersections are. Now, if you just start moving over, that's not going to get you exactly where you want to be. Also, if you just hit trace, it can get us close, but we don't know if that's dead on. I want you to be dead on accurate. So everything good for graphing is underneath calc. So I'm going to hit second, calc. Notice we have this option, number 5, called intersect. I'm going to select that. My calculator is going to die. I'm going to go grab my other one. Now I have to re-input. All right, here we go. -2 natural log of x plus 3 plus 2. Unfortunately, this doesn't have fancy calc, so this doesn't have the new operating system, so I have to do it the old way. That's all right. I should still get 3 intersections. There's my first curve, natural log decay. Or no, reflecting of a natural log. All right, so now, like I said, everything good is underneath calc. So second, calc. I'm going to select intersect. Now your calc is not going to ask you left bound, right bound, guess. It's going to say first curve, second curve, guess. So all I'm going to do is move this cursor as close as I can to the intersection that I want to find, and then hit enter, enter, and enter. Now that works as long as you don't have like 3 or 4 curves on the screen. If you have 3 or 4 curves, you have to be a little bit pickier about which ones you choose. All right, so I'm going to round to, let's go to 3 decimal places today. So -1 point, now I'm going to go to 2 decimal places. 1.97, comma, 1.94. I do expect you to round properly. So however many decimal places you go, you have to go at least 1 in this case to show that it was a decimal. But however many you go, you must round properly. So I found that intersection. Now I need to find this one. So second, calc, intersect again, move my little cursor, get as close as you can to where it is, and then enter 3 times. Enter, enter, enter. And we get 1.42, comma, -0.97. And because there was 3 intersections, we have to find all 3. So second calc again, intersect again, and I'm going to move my cursor as close as I can to where I think the intersection is, and then enter, jumps to the second curve, enter, and then take your guess, enter, and we get 2.54, comma, -1.42. So if you can graph without a calc, in other words, if you don't get this little symbol next to the problem, you should be able to graph that by hand. So on the test, I'm going to give you sections that are calc and non-calc. If you get this little symbol, you can use your calculator. Otherwise, you should be able to do it by hand. Let me box this in. All right, folks, good luck.